Hello students, today we are going to derive the relationship between the f1 first focal length of the lens system and the f2 second focal length of the lens system in a optical system. The relation between f1 and f2, or it can be written as f and f dash also. F and f dash for in a optical system. For this, consider this figure. In this figure here, the optical system is represented by the planes from the concept of the cardinal points. Also, we have represented here the figure. The A1, H1, K1 is the first principal plane. H1, H2 are the principal points, first principal point, second principal point, and this is known as the first principal plane. This is E2, S2, K2 is the second principal plane, and this is the principal axis. Now consider the here, so the optical system is represented by the two principal planes, first principal plane and the second principal plane. Now consider the object, that is AB, placed on the axis. Now consider to draw the ray A1 parallel to the axis. Whenever we consider this ray A1 parallel to the axis, it passes through the second focal point F2 of a lens system. So F2 is nothing but here the second focal point. So we will consider this first ray A1. After refraction, it passes through the second focal point F2. Now consider the second ray AF1K1 passing through the first focal point here. And according to definition, whenever the ray passing through the F1, after refraction, it proceeds parallel to the axis. So it is represented by the double arrow in the on the direction of the propagation of the ray here. And consider the third ray here, which makes an angle starting with B position and which makes an angle θ1 with the axis, which is represented by the three arrows on the direction of the propagation of the ray. And after refraction, it makes an angle θ2 with the axis. So A dash B dash will be the image of what here, the object AB. Now suppose here the H1K1, your H1F1 is nothing but here, the H1F1 is nothing but first focal length of the lens system, that is F1. The H2F2 is nothing but here the second focal length of the lens system, that is nothing but small f2 here. Also the medium or the y1 is equal to EB is nothing but height of the object, that is equal to y1 say. A dash B dash is equal to height of the image, that is A dash B dash is equal to y2 say. Here is nothing but y2, here is nothing but y1 say. The u is nothing but here, this distance h1b is nothing but here, the h1b is nothing but here, the u distance of the object from the first focal plane or the first principal point here. The S2b dash, this S2b dash is nothing but here, the distance of the image, that is nothing but v from the second focal point. This distance is nothing but here up to S2b dash is nothing but the v here, and the here is nothing but medium 1. This is the optical system which separate, this is the medium 1 and the other side medium 2. So suppose mu1 is nothing but here refractive index of the medium first, and the mu2 is nothing but what here, the refractive index of the medium 2. So these are description of this diagram. Now consider the right angle triangle A1, B and H1 here. So consider the right angle triangle here A1, H1B, H1B. Now from this right angle triangle we can write tan θ1 is equal to. So tan θ1, this will be equal to this side divided by this side. So A1 H1 here, the A1 H1 divided by H1 B or BH1, BH1. So using sign conventions we can write here tan θ1, this will be equal to, this angle is nothing but positive. So when the axis is rotated through an acute angle to make it coincide with the ray here, this is anti-clockwise direction. If we can rotate this principal axis through acute angle to make it coincide with this ray. We are getting theta 1, and theta 1 is always positive. While when this axis is rotated in clockwise direction to make it coincide with this ray, then this angle is negative. This angle is always negative due to sign convention, and this angle must be what here? This is positive. This is the positive angle. This is positive angle. So tan of plus theta 1 means theta 1. A1 H1. A1 H1 is nothing but this is, and this is nothing but what here? This will be the y1, height of the object, and this is lies above the principal axis, and therefore it is positive. So we are getting here the above y1. This is equal to y1 divided by bh1. bh1 is nothing but here. The bh1 is nothing but what here? This distance here, and this distance will be equal to du, and this lies to the left of the lens system, and it is opposite to the direction of the light we have measured, and it is always negative. So this is the, according to sign convention, this is minus u using sign conventions. So using here the sign conventions we can write here conventions. So we are getting this equation, tan theta 1 is equal to y1 divided by minus u using sign conventions. Now from the right angle triangle, we have to consider first of all right angle triangle this. Now consider right angle triangle this, that is A2 S2 B dash. Now consider E2 S2 and the B dash. So from this we can write tan theta 2. So tan theta 2, this will be equal to, this tan theta 2 is equal to this side, this angle theta 2, this is the right angle triangle, A2 S2 divided by E2 S2 divided by S2 B dash or B dash S2, B dash F2. Now by using sign conventions we can write, so this will be equal to tan of here, tan of minus theta 2 now, because this angle using sign convention theta 2 is always negative, so this will be equal to here E2 S2 is nothing but this, and this is nothing but again you are getting y1, and this distance lies to the above the principal axis can be taken as positive, so this is the y1 divided by b dash f2. So b dash f2 is nothing but this distance, b dash h2, not f2, b dash h2 here, b dash h2 here, this side, this tan theta 2 is equal to this side divided by total this side, and this is nothing but b dash h2, and this b dash h2 is found to be equal to this distance v minus this distance v. So we are getting here b dash h2, b dash h2 is nothing but v distance, so this is nothing but v distance, so we can write like this v distance, and this is positive. These distances are measured from this to this along the direction of the light. This distance is v is nothing but positive, and y1 is nothing but also positive, so we are getting this equation, and this which implies tan of minus theta is equal to minus tan theta 2. So this will be equal to y1 divided by that is v, and again tan theta 2 will be equal to tan theta 2. This will be equal to minus y1 divided by v. Negative sign goes to this side. So we are getting tan of theta 2 is equal to like this equation. Now consider tan theta 1 divided by tan theta 2. Now consider the ratio. Now consider tan theta 1 divided by tan theta 2. So this will be equal to tan theta 1 is equal to y1 divided by minus u. Here the y1 divided by the minus u here, and tan theta 2 here divided by again tan theta 2 means we can multiply it in inverse case by considering the tan theta 2 as the inverse. minus y1 divided by v we are getting. So v divided by minus y1 we are getting. V divided by minus y1. So we are getting like this equation. Now this will be equal to, this comes out to be equal to here, this comes out to be equal to, which implies here tan theta 1 divided by tan theta 2. Tan theta 2, this will be equal to, y1 get cancels, minus into minus become plus phi divided by u. So we are getting, this is phi divided by u. And if suppose this is the equation 1, so we can write here, that is important equation, we useful in the next portion of the derivation. So we can write here tan theta 1. So what we have derived, tan theta 1 divided by tan theta 2. Tan theta 2 will be equal to phi divided by u. So this is phi divided by u. So suppose this is the equation 1 here. Now consider the similar triangles here. So to derive, this is somewhat the big derivation, and after derivation we are getting small relation. So here, now consider, in this case we have to remember here the two triangles we have to consider similar triangles, E2, S2, F2, E2. Now consider these two similar triangles here, the E2, S2 and F2, and the other triangle here, the similar triangle, this one, A dash, B dash, F2, A dash, B dash, F2. So we have considered these two triangles, this triangle and these triangles are similar, just like you and your photo are the similars. Similarly here, the A2, S2, F2 is this triangle, and similar triangle is A dash, B dash, F2. So what we have to take here, the ratio of the corresponding sides of the small triangle. So in this case we have to consider small triangle divided by ratio corresponding sides, ratio of the corresponding sides of the big triangle. Small triangles divided by big triangles. So from this equation we are getting A dash, B dash here. So what we can write is here the A dash, B dash. So A dash, B dash, this divided by this side divided by corresponding side of the big triangle, that is A2, S2. So here the A2, S2, this will be equal to, now similar triangle, small triangle, the another side B dash of 2, B dash of 2 here divided by S2, F2. Here we are getting S2, F2. So S2, F2 here. So this will be implies. So again we can use here the sign conventions. The A dash, B dash, this will be equal to minus 1. Isn't it? This is nothing but what here? The minus y2. This is the minus y2 divided by A dash, B dash. Because the distances which are measured below the principal axis is always negative. So y2 is nothing but here the minus y2 divided by E2, S2. E2, S2. This is nothing but the distances which are measured above the principal axis can be taken as positive, and this E2, S2 is nothing but what here? This is the y1. So this is here the y1, and this will be equal to here we are getting B dash of 2. Now B dash of 2 is nothing but what here? This B dash of 2 is nothing but this distance here. This is total phi distance minus this distance gives rise to this distance. So phi minus f2, this is phi minus f2 divided by s2 f2 is nothing but what here? The again we are getting that is f2. Here is nothing but f2. And these distances are positive. Therefore, whatever we are getting will be like this. Divided by here is nothing but what here? df2. So which implies phi minus f2 is equal to, from this equation we can write phi minus f2 is equal to here df2, take to this side, minus we will take here this side, so minus y2 divided by the y1 into yf2 here. Here we are getting y2 f2 divided by y1. So we are getting, this is the next equation, that is 2 equation. So I will also write here, which is useful in the next portion of the derivation, v minus f2. V minus f2, this will be equal to minus y2 divided by the y1 into here the f2. So this is the equation number 2 here. Now also we will take into account the another similar triangles here. Another similar triangles we will consider. This is the big triangle E2S2 E2 K2 A dash. So consider the similar triangles E2 K2 and A dash and the other triangle, this triangle, and similar triangle, this triangle. So E2 S2 F2 E2 S2 F2 here. So what we can write? We will take the small triangles divided by the length of the side, ratio of the length of the sides of the corresponding sides of the small triangle divided by big triangle. So small triangle we are getting like this, A2 S2 here. So we are getting A2 S2 divided by big triangles, that is this triangle. So A2 K2 here, B2 K2. So this will be equal to the similar triangles here. Now small triangles S2 F2, this S2 F2 divided by similar side of the triangle, that is K2 A dash here, the K2 A dash. So this will be equal to again. So by using sign conventions here, the E2S2 is nothing but y1. Here is nothing but what here? The y1 divided by E2K2. The E2K2, this side, this is nothing but y1 distance, and this distance is measured below the principal axis, and this is nothing but what here? y2. So this much distance is nothing but what here? The y2, and but here is negative sign according to sign convention. So total distance we are getting y1 plus minus 2 means y1 minus y2. So this is, remember here we are getting y1 minus y2 here, y1 minus y2, and this will be equal to S2 F2. The S2 F2, this distance is measured along the direction of the light from the origin of the lens system, that is it is positive. This is F2 here divided by K2 A dash. Here is nothing but K2 A dash, and it is nothing but distance what here? It is distance nothing but phi. So this will be equal to nothing but what here? dp. So this is the equation number 3 say. So we are getting these 3. Similarly from right, similar triangles we are getting this A1 K1, this triangle, and a small triangle this we are getting A1 K1, A1 K1, and the other triangle is nothing but F1 H1 K1, F1 H1 K1. These are similar triangles, F1 K1 A1, F1 K1, F1 H1 K1, F1 H1 K1, or F1 K1 H1 say. So this is F1 K1 H1. This is the another triangle. So from that triangle we can write here the always small triangle sides divided by big triangle. Small triangles H1 K1. Here is nothing but we can write H1 K1 divided by A1 K1 divided by A1 K1. This will be equal to this side divided by chote triangle divided by big length of the big triangle. It is equal to chote H1 F1 here, the H1 F1 divided by this side AA1. This is divided by AA1. This is AA1. Now using the sign conventions we can write H1 K1. This is H1 K1 is nothing but y2, and it has negative sign because it lies below the principal axis. So here is nothing but minus y2 divided by A1 K1. This is A1 K1 as usual. This is y1. This is minus y2. We are getting A1 K1 is equal to y1 minus y2 here. y1 minus y2. So this will be equal to h1 f1 is nothing but first focal length of the lens system, and it lies to the left, and therefore left and in the opposite direction the distances which are measured in the direction opposite to the direction of the light from the lens system can be taken as negative. So f1 is nothing but here minus sign, here the minus f1 divided by a1. This is the a1 and this is equal to u is also negative. So here is nothing but what here, the minus u, and this will be equal to f1 minus minus become plus. So we are getting f1 divided by u. So this is the next. So directly we can write here the, which implies here minus y2 divided by y1 minus y2. This will be equal to f1 divided by u. So this is the fourth equation. Now adding equations 4 and 3 and 4. So adding these equations, two equations, we are getting y1 divided by y1 minus y2 plus this plus y1 minus y2, denominator is same. So we are getting y1 minus y2 here. So adding equations 3 and 4. What we are getting is here, in denominator you are getting y1 minus y2, y1 minus y2, and here upper side adding y1 minus y2, we are getting here the y1 minus y2 here, and this will be equal to, by adding this, f2 divided by p, f2 divided by p plus we are getting f1 divided by u. Here the f1 divided by u. Now this will be equal to, this is y1, this becomes 1, get cancels. So this will be equal to f2 divided by v plus f1 divided by u. Again we will take to this side. So which implies 1 minus f2 divided by v. So this will be equal to f1 divided by u. f1 divided by u. Take the LCM. So what we are getting is here the v, and here is nothing but v minus f2, and this will be equal to f1 divided by u. So this will be equal to, we will take v to this side. So what we are getting, v minus f2, v minus f2 is equal to f1 into v divided by u. V goes to this side. So v divided by u, v minus f2 is equal to, we are getting this equation. Now by putting the values of v minus f2 is equal to this much, and v by u, that is tan theta 1 by tan theta 2 in that equation. So what we are getting is here, so putting that values, we are getting the equation. So this will be equal to, v minus f2 is nothing but minus y2 f2. So further we are getting minus y2 f2 minus f2 divided by y1. This will be equal to f1 kept as it is here, and v by u is nothing but tan theta 1 divided by here tan theta 1 divided by tan theta 2. So what we are getting, v minus f2 is equal to, we will put from equation 2, the value is nothing but this minus y2 f2 divided by y1, and f1 kept as it is, and instead of v by u we can write tan theta 1 divided by tan theta 2. So we are getting that equation. So this equation can be written as in the usual form here. The tan theta 2 we will take here. So minus y2 tan theta 2 divided by, take this to this side, y1 tan theta 1. So this will be equal to here the f1 divided by f2. So So this goes to here, tan theta 1 goes to here, tan theta 2 goes to upper side, and F2 is here. So we are getting this equation. So we will change the sign here to this side. So y2 tan theta 1 90 tan theta 2 divided by y1 tan theta 1 this will be equal to minus f1 divided by the f2. So we are getting this equation. Now we will use the one important law, what we call as the Helmholtz law. So according to in optics, there is a one law what we call as the Helmholtz law. So Helmholtz law, and according to this law here, we are getting, if suppose this is the principal axis, and this is the optical system, say here, this is the medium 1, we can represent it as the refractive index mu1. This is medium 2, can be represented as refractive index mu2. Here is nothing but mu3, and so on. If suppose the object is placed here, then, and if suppose we have drawn the line here which makes an angle theta 1, here the theta 1 angle makes, and we are getting image somewhat here. We are getting the image here, and it makes the angle. So this is the incident ray. After refraction, it will make an angle theta 2. Here if suppose theta 2, here is nothing but theta 2. And this image can be act as an object for this system, another lens system. So here we can draw the another ray here. Suppose this is the ray which makes an angle here theta 2, and then we are getting the image somewhat here. That is, it makes an angle theta 3, say. Then there is one law. If there are n media given the refractive index mu1, mu2, mu3, then if suppose this is the y1 is nothing but height of the object, here is y2 is nothing but height of the image here. Similarly here the y3 is nothing but the height of the image. This image can be act as an object for the next system. So this is the image, that is nothing but y3, and so on. Then we are getting one law, and that law is known as Helmholtz law, and it is given as mu1 y1 tan theta 1. This will be equal to mu2 y2 tan theta 2, and this will be equal to also mu3 y3 tan theta 3, and so on, tan theta 3, and so on. If there are n media, we can write like this, Helmholtz law, and that law can be regarded as here. We can write from this equation mu1 y1 tan theta 1. So from this law we can write here y1 tan theta 1 divided by y2 tan theta 2. We will take to this side. We will consider only the two terms here. So y2 tan theta 2 will be equal to here, and mu2 as it is kept here, the mu2 divided by the mu1. Here is nothing but mu1. So from this equation we can write like this. So with the help of this equation we can write here. You have to convert this. So we are getting mu1 divided by mu2. So we are getting here y2 tan of theta 2. So y2 tan of theta 2 we are getting here. Y2, invert that equation, tan of theta 2 divided by y1 tan theta 1. This will be equal to mu1 divided by mu2. mu1 divided by the mu2, and we will put this value in this equation. So this equation becomes further mu1 here, the mu1 divided by mu2, this will be equal to minus f1 divided by the f2, and this is known as, this is the required relation between the f1 and f2, and we are getting refractive index of the medium 1 and the medium 2, that is mu1 mu2 divided is equal to minus f1 divided by f2. If the medium on both sides of the optical system is same, then mu1 is equal to mu2. Then this refractive index must be equal. If medium same on both sides of the optical system, mu1 is equal to mu2. And this equation can be written as, here the 1 is equal to minus f1 divided by the f2, or simply we can write here, which implies here the f1 is equal to minus f2. So the f1 and f2 has always opposite side. F1 and f2 have always the opposite sides, and this is the required relation, and this may be asked for the MCQ questions. So you have to concentrate on all these, how to derive the f1 and f2. The method somewhat is tedious. So here we have considered the similar triangles, and we have to consider small triangle divided by big triangle sides, and if we can take that ratio, then it is possible to derive, it is very simple to derive the relationship between f1 and f2 or in the optical system. Now in the chapter, the one point is remaining, that is we have to see what is meant by lateral magnification, axial magnification and the angular magnification. Three magnifications, we have to see the definition in the next article, and we have to derive the relationship between them. Okay, thank you.